Okay, earlier we have tried to put the keyboards to our processor, and we did use small 7-segment display, but in this section we are connecting the LCD display to our processor. Here's the idea how we will do that. Here is the LCD display, which contains 2 rows and 16 characters. And here's our connection board, and here's our Arduino processor. And in next slides we show how to make these connections here, but we will use these wires to connect our display to our processor. What we have to connect is that we have to connect, there's a data bus in the display, and we are using that now as a 4-bit mode. So we are using only 4 bits of the display's data bus. And that will be connected to this D and P board in Arduino processor. There is also power supply lines, plus 5 volts, and ground line and contrast voltage, which will control the contrast of the display. And then there are some command lines, RS and E, which is used for the controlling the data bus of the display. Here is the schematic diagram how to connect the wires. Here is the LCD display, and here's the Arduino processor. And here are the wires that we have to connect between the LCD and the Arduino processor. And this is also what you have to remember, that there is that contrast adjust potentiometer, trimmer potentiometer that you have to connect there. And with this line you can adjust the voltage between 0 and 5 volts to control the contrast of the display. Here's also one clarification how to connect these wires. This is the Arduino side, and here's the display side. And you have to connect these 4 data bits here. And these 4 data bits from display you can left off, so no connection for these. And then we have to control the control signals also, and the power supply lines. And notice that some of these displays, these markings has been marked for the connector here, so you can read the signal meaning here from here. After wires has been connected, then we can go through and look a little bit at the program. We are including the already made liquid crystal library program, so we don't have to take care of each bit of the display. So we can use this LCD library functions, so that makes the things a little bit easier than to write the very low level program. So we don't have to write a low level program, we can use these library functions. How to include the library? It's that we will use this include tag here and use this liquid crystal edge library. That we have to put in the beginning of the code. And first thing after that is that we have to define the wire connections. So it means that here are these LCD display pins, and we have to tell the library program where those pins has been mapped in the Arduino processor. And these numbers here equal this 1 means the signal D1, D0, D5, D4, and so on. So we can in fact change the pins in Arduino side where we connect the display, but in this liquid crystal command we have to tell that in which pins in Arduino side the signal has been connected. So it's possible to change these pins, but in here we have to tell the library in which order the signals are connected in Arduino side. And next thing is that we have to tell the library, LCD library, which size is our display. If we give command lcd.begin 16.2, it means that there are 16 columns, 2 rows, 16 characters and 2 rows. That tells the library what size of the our display size. And after size definition, our display is supposed to be ready, and then we can start the printing to display. As there are several characters in the display, several character places in the display, we could define where to start the printing. And there is this LCD set cursor command, and in the first number here says that which is the row number, the row place. Which is the column place, and the second number here tells what is the row. In our small display there are only rows 0 and 1, 0 and 1, as there are 2 rows, and this number could be something from 0 to 15 because it's still the column place. So if we give command LCD print, and then there's some text inside the brackets, this tells to the library function that print to display hello. And if we want to print numbers, if we have a variable, integer variable I, if we give command LCD print I, it will print the number, the value of the I. And if we would like to print float numbers, it's basically the same kind of print statement, print command, but we add also the number of decimals that we would like to print to that float. So for example, this means that let's print a float variable f, and the printing will be done with 3 decimals. Here is the screenshot of our example program. So in here we include the LCD library, here liquid crystal, and then we will define the wiring order to the library. These were these D lines, D numbers here, and here are the signals of the display. And then if we go to setup side, in here we define the size of the display. It was 16 characters and 2 rows. And here's the first printing command. We are printing to display Hello 2016. And if we go to loop side, here is the first we define the cursor to point 1.1. So this means the second row and second column. And in here we are printing the variable I. So as you see here, there's a for loop I from 0 to 10, and in here we are printing the value of the I. So it will print the numbers from 0 to 10, and between the numbers it will wait a little bit less than 1 second. Here is the example picture about the earlier program, tutorial program. It prints the hello 2016, and here is that variable I, which is rounding from 0 to 10. And as we defined that the place 1 to 1, the second row, and the second column, it's starting the printing here. And that hello was, the cursor to hello was defined for 0, 0. Now it's time for your own exercise. So to create a program that puts numbers from 0 to 50 on the left corner, and the same time the number goes from 50 to 0 in the right corner. Here is an example how it should look like. So here this number goes from 0 to 50, and same time this goes from 50 to 0. And here's the square root with 3 decimals, and here is the opposite number of the upper number. And in next exercise, exercise 13, so now use the keyboard also. So create a program that prints the numbers of the pressed key. When you press the key, it will print the number, print the pressed key number to display. You can use the keyboard read function that was created in earlier sections. And exercise 14. Now make program that will read 2 numbers from the keyboards, the printer numbers, same time when you are pressing those keys, and then print the sum of those numbers. So it's basically very simple plus calculation program. And exercise 15. Now let's try a very simple user interface exercise. So the idea is that there is a set value for whatever controller, whatever, and the idea is that you could increase the number by 1 or by 10, and you could decrease the number by -1 or -10. So it's a simple user interface to make adjust value to here to display. This is supposed to be the display, and make program in such way that the value never goes below 0 or never be over 100. So all the time the range will stay, the set value range in the display stays between the 0 and 100.